Hello, my name is Hakob Abajian, and today we're going to be talking about spontaneous processes in the AP Chemistry course. Thermodynamics can tell us whether a reaction is spontaneous or not. Our primary function is entropy. It is the measure of randomness or disorder. You can tell if a reaction is going to be spontaneous if you can tell that the entropy is going to increase. So this is all very conceptual, so let's get to the chemistry. Entropy is a thermodynamic function that expresses the available arrangements of a system. In other words, nature spontaneously proceeds towards the states that have the highest chance of existing. Now we can relate this to the states of matter. Now, solids have a much smaller amount of potential molecular configurations than liquids or gases. Gases have much higher amounts of molecular configurations because of the space that gases take up. Therefore, going from solid to gas, we are increasing the entropy and increasing the spontaneity. So a question comes up. The question is, what is the difference between the entropy of the system, surroundings, and the universe? Because all three are a little different. So let's consider this reaction here. Water from liquid turns into a gas. This is our system. Our reaction in the molecular form is just this water to water action and nothing else. Now we already know that gases have a more positional probability than liquids do. So we can already tell that this is going to increase the entropy of the system. So what is the entropy of the surroundings? The surroundings are anything in the universe that is not the system. Entropy change of the surroundings is mainly determined by the heat flow in and out of the system. So right away we can see that this reaction is endothermic, taking energy in to turn water into water vapor. In this reaction, heat flows out of the surroundings, therefore decreasing the amounts of random motions of the molecules, and therefore decreasing the entropy of the surroundings. Generally speaking, endothermic reactions result in a decrease of entropy in the surroundings, and exothermic reactions result in an increase of entropy in the surroundings. Because the change of entropy in the surroundings is determined by the change in temperature resulting from heat flow in the reaction, we can assume that the change of the entropy of the surroundings equals a negative change of enthalpy divided by the temperature. In our example, we saw a negative change of entropy in the surroundings and a positive change of entropy in the system. So does this mean that it is spontaneous or not? The change entropy of the system plus the change entropy of the surroundings equals the change entropy of the universe. Imagine that the change entropy in the universe determines the spontaneity of the reaction. In other words, the spontaneity of a reaction is determined by its total contribution to an increase of entropy. Another important thermodynamic function is free energy, or G. We can put it into this equation to understand it better. We can see an inverse relationship between free energy and the entropy change of the universe. Using our previous equation, there's another way to calculate the entropy change of the universe at a constant temperature and pressure. Now we have multiple ways how to calculate spontaneity. I hope this video was helpful. These topics in thermodynamics always confused me. However, if you look at it the right way, it's very basic.